Today is the first day of Unit 4, and we're going to start by talking about the triangle sum theorem. And we're going to be able to classify triangles by their sides, and we're going to be able to calculate the interior angles of a triangle and also the exterior angles of the triangle. So the angles inside a triangle are called the interior angles because they are on the inside. Angles 2, 1, and 3 here are all interior angles, and then angles 4, 5, and 6 are called exterior angles. Exterior angles. And notice that the exterior angles still touch that triangle. That this angle right here is not considered an exterior angle. So we're going to classify triangles by sides. The first one is called scalene. Scalene triangles have no congruent sides, so each side of the triangle is a different length. An isosceles triangle is when we have at least two sides that are congruent. Remember, these tick marks tell us that these two sides are congruent. An equilateral triangle is when all three sides are congruent. These tick marks here tell us that those three sides are congruent. So something to note is that an isosceles triangle is defined by having at least two congruent sides. An equilateral triangle has all three sides congruent, which means that every equilateral triangle is also an isosceles triangle because the equilateral triangle has at least two sides, and in this case three sides, that are congruent. But the reverse is not true. All isosceles triangles are not equilaterals, but all equilaterals are isosceles. I know that can be confusing, and it very rarely comes up. I just wanted to point that out. So then over here we can also classify them by angles. So an acute triangle is when all three angles are acute, which means less than 90 degrees. So each one of these angles is less than 90 degrees. A right triangle is when we have one right angle. You can't have a triangle that has two right angles because then the sum would be over 180, which is what we'll talk about later on. An obtuse triangle is when you have one obtuse angle. So one angle is bigger than 90 degrees, which means the other two have to be less than 90. And then equiangular triangle is when all three angles are congruent. And in an equiangular triangle, each angle is 60 degrees. Each angle is 60 degrees. So let's go down here and classify each triangle by its sides and by its angles. So I don't have any tick marks in letter A right here, so we do not know if any sides are congruent to each other. So we're going to call this scalene because all sides are different lengths. And then the only angle we're told is this 100-degree angle, which is bigger than 90. So then this is an obtuse triangle if we're going to classify it by angles. Then letter B, again, we don't see any markings on the sides, so we don't know if any of the sides are congruent, which makes this scalene again. And we have a right angle right here, so that makes this a right triangle. Then letter C, I see these two tick marks here, so we have two sides that are congruent. So this is an isosceles triangle. And the angles are all acute because we have 75, 75. and this angle is also less than 90. So all three angles are less than 90, making this an acute triangle. So something else to notice about isosceles triangles, if we go back and look at this, you see the angles that are across from the congruent sides. So I have my two sides here that are in pink that I marked, this side and this side. The angles across from them are also congruent. So that is a property of isosceles triangles, and we call those angles base angles. So the angles that are across from the congruent sides in an isosceles triangle, those angles are congruent. So it says that down here too, in an isosceles triangle, the two sides across from the two congruent angles are congruent. So here are my congruent sides. So the angles across from them are congruent. And now that we've kind of named all the types of triangles, we're going to get to the the meat of the lesson, and that's the sum of the interior angles of the triangle. So sum of the interior angles of a triangle is 180 degrees. And you may have already learned this, or we may have talked about it before, but now we're formally going to define it in our course. So now from this point forward, you need to know that every triangle, when you add up all the angles, it equals 180 degrees. All right, let's look at the next page. So it says write an equation and solve it to find the angle measures in the triangle. So we have 20 plus 34 plus 3x equals 180 because all the angles add up to 180. We can combine like terms here, so we're going to add 20 and 34. So we get 54 plus 3x equals 180. We'll subtract 54 from both sides. So let's do that. And we get 3x is equal to 126. Then divide both sides by 3. And then we get 42. And the problem is also asking us to find the measure of each angle. So right here, that angle is going to be 3 times 42, which is 126 degrees. And again, you can always double check. Get your calculator and add 20 plus 34 plus 126 and see if you get 180. You already have your calculator out. You might as well utilize it. Then letter B, let's take our angles. So 4x minus 5 plus 3x plus 5 plus 40 equals 180. So we'll combine like terms. 4x and 3x is 7x. Negative 5 plus 5 plus 40 is 40. So then we'll subtract 40 from both sides. We get 7x is equal to 140. And we divide both sides by 7. X is equal to 20. So now we have to plug 20 back in for each of these angle measures up here. So 4 times 20 minus 5 is 75. And 3 times 20 plus 5 is 65. So again, you can go through and add 75 plus 65 plus 40 and make sure you get 180 degrees altogether. All right, let's look down here. It says, in a triangle, one angle measures 44 degrees. Of the two remaining angles, one is 3 times the measure of the other. What are the measure of the two unknown angles? So for problems like this, you want to draw a picture, and it doesn't matter where you label the angles. You're just doing this to kind of help you out. So one of them is 44. Now, of the other two, one is 3 times the other. So like if one angle was 20, that means the other one would be 3 times 20, or 60. So if the smaller angle was 45, then the other one would be 3 times 45. So if the smaller angle is x, that means the other one must be 3 times that, or 3x. So then we'll do exactly what we did up above and have x plus 3x plus 44 equals 180. Then we'll combine our like terms. We get 4x plus 44 equals 180. Subtract 44 from both sides. So we get 4x equals 136. And if we do 136 divided by 4, we get 34. X equals 34. So that's the measure of the smaller angle right here, 34 degrees. And then the larger angle will be 3 times 34, which is 102. So this angle is 102 degrees. And like always, you have your calculator out. Like I said, add up 34 plus 102 plus 44 and see if you get 180 degrees. So this was the interior angles of a triangle. They all add up to 180 degrees. Now we're going to talk about the exterior angle theorem for a triangle. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two. These are called remote interior angles. Remote interior angles. So what this is saying is, if we look at the picture here, that the measure of angle 1 over here, which is at point C. Now, it's important to note that this is not the same as angle C inside the triangle. We're talking about this exterior angle here, this rotation right there. That is equal to the measure of angle A plus the measure of angle, let me put that M, measure of angle A plus the measure of angle B. So that's these two angles here. So if I add up those two angles in pink, it equals that angle in orange. So we can use that now to look at this diagram and solve for x. So we have 3x minus 9 is our exterior angle. And that's going to equal to the sum of the other two angles on the interior. So then we can solve this. We can add 9 to both sides and subtract x from both sides. So 3x minus x is 2x. Negative 9 plus 9 is 0. 73 plus 9 is 82. And x minus x is 0. So then let's divide both sides by 2. X equals 41. Now we can plug that in. The question says find the measure of angle DCB. DCB is my exterior angle. So 3 times 41 minus 9. So I'm just going to type that into the calculator here, and I get 114 degrees. So this equals 114 degrees. Now, in example number 2 over here, we don't have the picture labeled, we just have the text. So let's read it and label the picture. The measure of angle ABC is 47 degrees. So ABC. The measure of angle CAB is x minus 3. And the measure of angle ACD, so that's this angle on the outside, is 7x minus 4. So that exterior angle at 7x minus 4 is equal to 47 plus x minus 3. And we're asked to find the measure of angle BAC when we're done. So let's subtract x from both sides. 7x minus x is 6x minus 4 equals, I'm also going to combine terms. 47 minus 3 is 44. Then we'll add 4 to both sides. 6x equals 48. So then I'll divide 48 by 6. X equals 8. But now we need to plug that in for measure BAC. So angle BAC is this angle here that is x minus 3. So the measure of angle BAC is equal to x, so 8 minus 3, which is equal to 5 degrees. So yes, that doesn't look like a 5-degree angle, but that's why you trust the math. You don't just go based off the picture. You go based off of what the math is telling you. All right, now let's look at the next page. We have some complicated examples here. So we're going to find the values of x and y. And we see that we have our parallel lines here. So that tells us that we have all those alternate interior, alternate exterior, consecutive interior. All those things apply here. So if I look at my transversal in pink, angle that's 43 degrees is above the transversal. The angle that's x degrees is below the transversal. So those are alternate interior angles. What that means is that x and 43, those are the same angles. Those are congruent. Those are alternate interior. So x is just 43 degrees. Now, to find out y, I have a triangle right here. And in this triangle, my exterior angle here is 75. And I have two interior angles, the remote ones, the ones that are on the opposite side, that are 43 and y. So we can do 43 plus y is equal to 75. Subtract 43 from both sides, and we get y is equal to 32 degrees. So those are my two answers. So you really needed to use your parallel lines and transversal stuff. with example number 4, there are so many ways you could solve this problem because you have so many triangles here. And again, each triangle will add up to 180 degrees. What I like to do is I try to use the interior angle theorem or the exterior angle theorem first before I start looking at supplementary angles and stuff like that. So I see this triangle here, and the reason I'm going to look at that one is because I know my exterior angle here is 85 degrees, and I have my two remote interior angles of y and 25. So that means y plus 25 is equal to 85. So then we'll subtract 25 from both sides, and we get y is equal to 60. So I'm going to come up here and write 60 degrees. And they say, okay, well, what about x? Now, what triangle I want to focus on is this one. Because I have a remote, I have an exterior angle here. This box is 90 degrees. So I know that this angle that's 90 degrees should equal the other interior angles when we add them up. So I will add up x and y, which we know is 60 degrees, and that equals the exterior angle. That box means 90 degrees again. So then we can subtract 60 from both sides. We get x equals 30 degrees. So this one was more complicated. We had to look at some things before the other, and then make our way towards our answer. So it is useful to highlight triangles that you are working with. Like when we were doing the parallel lines and transversals, we ignored some transversals for the time being. Then the last problem here, right? All the angles in a triangle add up to 180. That box means 90 degrees. And the measure of angle A is 22 degrees. That means if I add these up, 90 plus 22 plus, we don't know what angle B is, so let's make it x, that equals 180. We combine our like terms. 90 plus 22 is going to be 112. Subtract 112 from both sides, and we'll get x equals 68 degrees. Now, a shortcut you could have done is that you could have said, well, I know all the angles in a triangle have to add to 180, so this angle is already 90, which means the other two angles must also add to 90. You could have just done 22 plus x equals 90. I don't know if that would really be much of a shortcut. It didn't take us much time to solve it the other way. So I hope that this video made sense. When we're working with triangles, you need to remember that all the angles on the inside add to 180, and then it's a puzzle where you figure out which pieces you have and which pieces you need to get your answer. So thank you for watching the video. Make sure you hit the like button and subscribe.